Welcome to the AP Calculus BC Multiple Choice Study Guide. Today we are running the full court offense through limits, derivatives, integrals, applications, differential equations, and slope fields. This exam loves patterns, and once you recognize the pattern, it is too easy. The goal is not to memorize every random problem. The goal is to know the high-yield moves, so when the question shows up, you already know where it is going. LeBron James. Let us start with limits and continuity, because every calculus concept is built on limits. For basic limit laws, plug in first if the function is continuous. If you get 0 over 0 or infinity over infinity, that is when L'Hopital's rule can enter the game. It says the limit of f over g can equal the limit of f prime over g prime, but only for those indeterminate forms. Do not just use it because you feel like it. That is rookie behavior. Two classic limits need to be automatic. The limit as x approaches 0 of sin x over x is 1. The limit as x approaches 0 of 1 minus cosine x over x is 0. If a rational function goes toward infinity, compare leading terms by dividing by the highest power of x. For continuity at x equals a, the function value must equal the limit. That means f of a must exist, the limit must exist, and they must match. If one-sided limits do not match, the full limit does not exist. Discontinuities are another high-yield zone. A removable discontinuity is a hole. Usually a factor cancels from the numerator and denominator. A jump discontinuity happens when the left and right limits exist but are different. An infinite discontinuity means the function shoots toward infinity or negative infinity, usually at a vertical asymptote. On multiple choice, if they ask how many removable discontinuities there are, factor the expression and count the denominator zeros that cancel. It is too easy. Now, derivatives. The definition of the derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. If multiple choice gives you that form, they are asking about a derivative. For rules, memorize power rule, chain rule, product rule, quotient rule, and implicit differentiation. Power rule brings the exponent down and subtracts 1. Chain rule says derivative of the outside times derivative of the inside. Product rule is u prime v plus uv prime. Quotient rule is u prime v minus uv prime over v squared. Trig derivatives are free points if you know the pattern. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of cotangent is negative cosine squared. Derivative of secant is secant tangent. Derivative of cosine is negative cosine cotangent. Big high-yield reminder, the cofunctions cosine, cotangent, and cosine have negative derivatives. No exceptions. Do not give away points. Exponential and logarithmic derivatives are also must know. The derivative of e to the x is e to the x. That function is special. The derivative of a to the x is a to the x times natural log of a. The derivative of ln x is 1 over x, and the derivative of ln of g of x is g prime of x over g of x. That is just the chain rule showing up in a different jersey. For inverse trig derivatives, know arcsin and arctan especially. The derivative of arcsin x is 1 over square root of 1 minus x squared. The derivative of arccos x is the negative version. The derivative of arctan x is 1 over 1 plus x squared. The derivative of arccos x is negative 1 over 1 plus x squared. BC loves arcsin and arctan. If you see ln of arcsin x, you need chain rule on top of inverse trig. That is a two-move combo. The big derivative theorems are mean value theorem, Rolle's theorem, intermediate value theorem, and extreme value theorem. Mean value theorem says if a function is continuous on a closed interval and differentiable inside, then somewhere the instantaneous rate equals the average rate. Rolle's theorem is the special case where f of a equals f of b, so some derivative equals 0. Intermediate value theorem proves a function takes every value between two outputs. Extreme value theorem says a continuous function on a closed interval has a maximum and minimum. Applications of derivatives are where the exam checks whether you understand the meaning. If f prime is positive, f is increasing. If f prime is negative, f is decreasing. Critical points happen where f prime equals 0 or does not exist. If f double prime is positive, the graph is concave up. If f double prime is negative, the graph is concave down. An inflection point needs a change in concavity, not just f double prime equals 0. You need the sign change. Particle motion is very high yield. Position is x of t or s of t. Velocity is the derivative of position. Acceleration is the derivative of velocity, or the second derivative of position. If velocity equals 0, the particle is at rest. If velocity is positive, it moves right or up. If velocity is negative, it moves left or down. Speeding up means velocity and acceleration have the same sign. Slowing down means they have opposite signs. And remember, total distance is the integral of absolute value of velocity. Displacement is the integral of velocity. They are not the same thing. Linear approximation uses the tangent line formula L of x equals f of a plus f prime of a times x minus a. Related rates means differentiate both sides with respect to time, and the chain rule is the main weapon. Optimization means find critical points, but on a closed interval, you must check endpoints too. Do not walk off the court before checking the corners. Integration is reverse differentiation, but BC wants technique recognition. Basic antiderivatives must be automatic. Integral of x to the n is x to the n plus 1 over n plus 1 plus c, as long as n is not negative 1. Integral of 1 over x is ln absolute value of x plus c. Integral of e to the x is e to the x plus c. Integral of sine is negative cosine, and integral of cosine is sine. Integral of secant squared is tangent. Integral of 1 over 1 plus x squared is arctan x. That arctan form is a BC favorite. The fundamental theorem of calculus is another automatic bucket. If you differentiate an integral from a constant to x of f of t dt, you get f of x. If the upper limit is g of x, then you get f of g of x times g prime of x. That is FTC plus chain rule. For definite integrals, evaluate using an antiderivative f of b minus f of a. Also no properties. Switching limits makes the integral negative. Same limits give 0. You can split intervals, pull out constants, double even functions over symmetric intervals, and cancel odd functions to 0. Integration techniques are about choosing the right play. Use U substitution when there is an inside function and its derivative nearby. Use integration by parts for products of different function types, with the formula integral u dv equals uv minus integral v du. LIAT helps choose u logarithmic, inverse trig, algebraic trig, exponential. Use partial fractions for rational functions when the denominator factors. Use trig substitution when radicals like square root of a squared minus x squared, a squared plus x squared, or x squared minus a squared appear. Applications of integration bring area and volume. Area between curves is the integral of top minus bottom, or right minus left if you integrate with respect to y. Disk method uses pi times the integral of radius squared. Washer method uses pi times the integral of outer radius squared minus inner radius squared. Cross sections use the integral of area of the cross section. If squares are perpendicular to the x-axis and the side length is f of x minus g of x, then volume is the integral of that difference squared. If the rectangle height is 5 times the base, the area is 5 times base squared. Differential equations are the final stretch. For separable equations, separate x terms and y terms, then integrate both sides. Exponential growth has dp over dt equals kp, giving p equals initial amount times e to the kt. Logistic growth has dp over dt equals kp times 1 minus p over L, where L is carrying capacity. The logistic solution looks like L over 1 plus a e to the negative kt. High yield fact, fastest logistic growth happens at p equals L over 2. That is also the inflection point. Euler's method estimates solutions step by step using y new equals y old plus h times f of x old, y old. Keep the step size organized and update one point at a time. For slope fields, the slope at each point comes from plugging x and y into dy over dx. If slopes stay the same along vertical lines, the differential equation may depend only on x. If they stay the same along horizontal lines, it may depend only on y. A solution curve follows the flow and must pass through the initial condition. Final review. AP Calculus BC multiple choice is about recognition. Limits need special forms and continuity rules. Derivatives need formulas, signs, and meanings. Integrals need antiderivatives, FTC, and technique selection. Applications need interpretation, especially motion, area, volume, and growth. If you memorize the high-yield formulas and practice spotting the pattern, you are not guessing. You are reading the defense. And when you read the defense, you already know the next move. It is too easy. LeBron James.